we did a few calculations of logarithms without calculator, actually using these properties of logarithms by playing with the numbers, playing with the arguments. What do I mean by playing with the arguments? Like trying to write those bases or those arguments as powers of some particular number, and that particular number is the base of the logarithm. So that's what we did here. And the last one that we did was log base 10. Well, recall, no subscript for the logarithmic function means log base 10 or common logarithm. So, in this case, well, our goal was to write this number as a power of 10. So 10 to the second to the 1/3, and then we managed to do some manipulations there to eventually cancel the log symbol with the exponential symbol. All right, so that's our goal. Now, let's look at letter K, and well, what do we have for letter K? Log base square root of 3 of 9. Well, in other words, they're asking us what power of the square root of 3 equals 9. But we're not going to go back and forth between exponential and logarithmic anymore. So now we will use properties of logarithms. All right? Okay. How do we go about this? So, somehow we need to have a match between the argument and the base of the logarithm. And well, 9 is not equal to the square root of 3, so we cannot just cancel it yet. So we need to play with powers, and well, you'll see somehow this number 9, we're going to turn it into the square root of 3. Well, what's the trick? Well, number 1, well, if the base of the logarithm was a 3, we could have just written 3 to the second power and cancel the log base 3 with the 3, final answer 2. Well, unfortunately, the base is not just 3, it's the square root of 3, but still we're going to use the idea before to begin with. So, log base square root of 3 of how about 3 squared? And well, somehow like is shading here because we have a 3 but not quite the square root of 3, you know. So this is what I'm going to do next. I'm just going to use grouping symbols. Log base the square root of 3 of 3 to the second power, and that just to focus on the number 3 without having immediate powers that kind of bug us here. So, okay, here's the trick. We can any number. Well, let me talk about this number 3. You know, okay. So the number 3, it's the same as saying in terms of powers. How about okay? Can we write the number 3 as the square root of 3? Well, these two numbers clearly are not the same. We agree with that? Well, what do we need to do with the square root of 3 so that it becomes a 3? Square, all right? Likewise, 3 is the same as the cube root of 3, quantity cube, because the cube cancels the cube root, taking us back to the right again, which is just the number 3. Likewise, 3 equals to the 7th root of 3, but raised to the 7th power, and that's because here power cancels radical, cancel powers radical, cancel powers radical. I know it's kind of silly to look at this because usually we do calculations in this direction. We simplify, all right? What we're doing here is not simplify, but rather amplify, if we will. And the reason why we amplify this is to somehow find a match between the base and the logarithm, between the argument and the base of the logarithm. So now I'm going to, okay, let me erase this. We don't need this. I only need this one. So I'm going to go ahead and write log base 3, log base square root of 3 of, what's this? The square root of 3 quantity squared. Okay? And we are almost there, except for how about we simplify the exponents. Power of another power, we multiply the powers. Log base the square root of 3 of the square root of 3 to the 4th power. And check this out. We have a match between the argument and the base of the logarithm. And check this out. Cancel, cancel. And that equals to 4. Final answer. Okay, so well, I think this is the end of this section. I wanted to save this exercise for today for a good warm up. I felt like if I did it before finishing class the other day, I was gonna rush through it, and I didn't mean to do that. So let's see. Go back to, I think this is the one. All right. So the next section for today is properties of logarithms. Actually, further properties of logarithms. So we already covered some of them, some of the very basic ones. So we are going to expand these properties. And well, the reason we will look at this is because later we will work with logarithmic expressions that we need to simplify as multiple terms or compress them into one single term. And that's actually something you will use later in calculus and differential equations and other subjects, even in physics perhaps, physics and chemistry, a lot in science as well. And actually, these properties will help us simplify a lot of expressions and, of course, simplify our work. Well, so the properties, the three basic properties of logarithms, like, so what do we have? We have the product rule, we have the quotient rule, and we have finally the power rule for logarithms. Well, so the product rule tells us that the logarithm base b of the product of two numbers is the sum of the individual logarithms. The quotient rule tells us that the logarithm of a quotient tells us can be written as the difference of two individual powers. All right, and the power rule tells us that, well, whenever we have a power, that power becomes a coefficient, or vice versa. Well, how about I'll give you like very simple examples of each before getting into the bigger examples. Well, so log of mn. Okay, how about okay, let me write log of, I'm gonna say 3x, for example. Log base 7, and I'm just going to make up a base. It doesn't matter. Log base 7 of 3x. So in this case, the 3x will be the argument. The 3x is the argument, and notice the argument is a product. It's a product between a number and a variable. So in accordance with the product rule, this can be written as a log base 7 of 3 plus the log base 7 of x. And that's how. Let me give you another simple example to this to illustrate how far can we go when situations like the one I'm going to show you. Okay, I'm going to stick to the logarithm base 7. Okay? So log base 7 of 35. But hold on. That doesn't look like the product between two numbers. There's two digits, but it's a two-digit number, not a product. So the first thing we might want to do is write the number 35 as the product of two numbers, or more, whenever the case. Well, I chose this number because it's simpler. And well, so we can write the number 35 as a log base 5. That's a log base 7 rather. 5 times 7, and that equals to 35. Now that we wrote this as a product, we may go ahead and use the product rule and break it up into the addition of two logarithms. So that's going to be log base 7 of 5 plus log base 7 of 7. All right. Now, so here's the thing. Let's see. Although we're essentially done simplifying using or expanding the logs using the addition of the two logarithms, log base 7 of 5 is simply log base 7 of 5. However, what about log base 7 of 7? Isn't that a property we did in the previous section? We can simplify this to 1. And well, we can go the extra mile and log base 7 plus 1. All right? And careful, because this plus 1 is not part of the argument. It's just plus 1. All right? Okay. Let's look at the quotient rule. So for the quotient rule, what if we have like I'm going to use ln this time. We can use any base we want, whatever the base we're given. ln of, I don't know, maybe 3/2. This will be simply ln of 3 minus ln of 2. That's it. That's how this works. Just the difference of the logarithms coming from a quotient. And well, let's talk about the power rule, which is essentially, okay, let me give it another name. You usually call this the basketball smackdown rule. Why is that? Well, when we go in this direction, check this out. So if we go in this direction, from right to left, what's going on? The power becomes an exponent. I mean, the coefficient becomes a power, an exponent like basketball. And on the other hand, when we go the other way around, here the power jumps to the front like smackdown. All right? Smackdown basketball rule. All right, so we're going to refer to this more often than not. I think it's a catchy way to keep this in mind. So what happens based on what the power or what the exponent or the coefficient is doing. All right. Okay, so and I mean, let me give you just a baby example here just for the warm up. How about log base 5 of, how about 49? All right, well, apparently there's no power, there's no power at all, but we can write the number 49 as a power of 7. That's 7 squared, and we can go about the number 2, put it in the front like smackdown, and 2 log base 5 or of 7. All right? And backwards, well, if we were to go backwards, well, that would have been basketball. Well, you'll see how we're going to use these properties for more complex expression, for more elaborate expression. So let's go ahead and go through those expressions. So more often than not, instructions usually look like, well, write each expression as a sum or difference of logarithms. And as a given, you will be an expression that contains only one single log and a bunch of stuff inside of the parentheses, a bunch of products, quotients, powers, and the like. So for this first example, log base 5 of u to the third power v to the seventh power. So there's a couple of things going on at the same time. So we are seeing the product between u cubed and v to the seventh, but we also see powers. Which ones do we go about first? So whenever that happens, think of this as having a product, you know, this mean product. So use the product rule. So we're going to do one step at a time. Log base 5 of u to the third power plus log base 5 of v to the seventh power. Okay? And well, once we're done breaking up these two logarithms as an addition by the product rule, we can go ahead and use smackdown rule. Put it in the front. Smackdown, smackdown. So do that twice. And those exponents become coefficients. Now, if you wonder why do we do this, okay, let me explain to that. So, okay, logarithmic expressions most of the times are going to help us simplify our calculations. Now, let me do some highlights here so we can compare between one and the other. Suppose that you are trying to compute some calculations. You don't have a graphing calculator with your any kind of calculator, right? Now, you will have to do these calculations by hand. Now, let's think about what's better. Would you prefer to raise a number to the third power, that is, multiply the number by itself 3 times, or do you just prefer to multiply one number times 3? What would be more efficient? What would be easier? The second one, right? It's easier to just multiply than 3 than cubing and handling. In this case, we would be handling smaller numbers rather than huge numbers. I mean, even squaring numbers can get big real quick. Now imagine cubing numbers. That's going to take, you know, some good time. All right. Let's look at letter B. Letter B, what do we have? ln of x over e to the x, and the whole thing is raised to the 2/3. All right. So number one, to begin with, well, there's a couple of things going on. Number one, we have a quotient. That means we're going to use the quotient rule. However, we cannot do the quotient yet because in this case, we have an exponent, and as opposed to the previous example, this exponent is affecting both terms. Over here we didn't do the exponent first because each factor were independent. Each factor had its own exponent, so that's why we saved that until the end. In this case, since the 2/3 is affecting both, well, we're going to use the power rule, aka the smackdown rule. And all right, taking some time, and that's a 2/3 ln of x over e to the x. All right. So now that we don't have anything extra to that quotient x and over e to the x, we're free to use the quotient rule. And careful how we use the quotient rule, because number one, it's going to write 2/3. I'm going to open bracket, and I'm going to write a difference here of two logarithms. And the reason to this is, well, ln of x minus ln of e to the x. The reason to this is that this coefficient, these 2/3, will affect both both of the terms inside of the brackets. Well, it seems like we are pretty much done with it, right? However, we can simplify this even further. Any ideas? What can we do about it? Yes.
Quick question. Why can't you just use parentheses instead of the brackets, or is it really different?
Like distributing the 2/3?
Yeah.
We can do that. However, before simplifying, distributing the 2/3, there's something we can simplify over here.
Yeah.
But yeah, we will do that in the next step. Any other ideas? What can we do to simplify? Anyone? Yes. Exactly right, because we have an exponential base e, and we have an ln, which is log base e. These are inverses of one another. So simplify this. That's 2/3 ln of x minus x. All right, and now we can distribute the 2/3. We could have done it before and then simplify the ln with e. With the e, it doesn't matter. And then that's 2/3 ln of x minus 2/3 of x. Final answer. That's it. So these are two separate terms. Actually, it would help if we put parentheses, some parentheses around the x, just so we don't get confused about this negative 2/3 to be part of the argument as well. All right? So let's see. It looks like that's a couple of examples. Let's move on to more examples, more elaborate examples. What do we have? Oh my God! It's log base 7 of the quantity y squared over 9, all divided by 7y times the square root of y squared plus 2y, and the whole thing being cubed. All right. Again, because the cubed right here affects both the numerator and the denominator factors, you might want to simplify this by the smackdown rule. So have the exponent to jump in the front and become a coefficient. Okay? And so that's going to be 3 times log base 7 of the quantity y squared minus 9. Well, you know what? No, let me leave it like this. And 7y square root of y squared minus 2y. All right? So number one, there's a couple of things we could do. Notice the quantity in the numerator, y squared minus 9. Did you notice that? Yes.
Why is it minus 2y instead of plus 2y?
Because I don't know. Thank you. It's a plus. So notice the quantity in the numerator. That's y squared minus 9, which has a very special form, a very well-known form. Does anyone know what form is this? Perfect square, difference of squares. So we can factor the difference of squares. Let me write that down at the top, just so you can see what am I doing. A squared minus b squared equals a minus b, a plus b. So what we can do in this case is simplify that difference of squares. Log base 7 of the quantity. That's a y minus 3, y plus 3, or y plus 3 times y minus 3. Order doesn't matter. In this case, it's product, it's multiplication. That's not going to matter at all. And we'll divide that by 7y, square root of y squared plus 2y. All right. This exercise is going to take a good minute to go, so let's bear with it, because there's a lot going on. We're going to have a product in the numerator and still products in the denominator, and on top of that, another radical. Well, you'll see how everything is going to work out in the end. All right. I know there's a lot going on. Again, sorry, I repeat myself about it. We have a product and product, but I mean the first thing we want to see about the expression inside of the logarithmic function, that is the argument, is a quotient. It's a quotient of something weird and another something weird. So that's going to be 3 times. I'm going to use the product, the quotient rule, and the quotient rule writes the two logarithms as a difference of them. So that's 3 times log base 7. Well, 3 times, I'm going to write brackets for this. 3 times log of y minus 3 times y plus 3 minus log of this madness in the denominator. I know there is a product and I know we can furthermore write it as a product, but let's do one at a time. So that's base 7 of 7 y square root of y squared plus 2y. All right. So far so good. Let me know if there's anything like not making sense, because I mean this one is going to take a good minute to go, and if there's something you get stuck on something, feel free to stop me at any time. All right. So what? Okay. I know there's a lot of symbols, but essentially this is some sort of log m minus log n, right? It's a quotient that was written as a difference. Now, if we look at these two expressions individually, we can have by the product rule. By the product rule, we can write this as let me see if I can make this smaller. I'm gonna need more space. Okay. Apparently I can. All right. So this will be 3 times bracket by the product rule log base 7 of y minus 3 plus log base 7 of y minus 3. And then minus, okay, careful with this minus, because this minus ultimately will affect everything that we have over here. In fact, you know what? I changed my mind. I'm going to write it in the next line just to ensure that I have all the space needed for this. Okay, so minus, I'm going to change grouping symbols to curly braces. And that's going to be bracket log base 7 of, notice in this case for the second term, check this out. We have the product between 3 quantities. The quantity 7 times y times that humongous radical. All right? So, that's a log base 7 of 7 plus log base 7 of y plus log base 7 of the square root. You know what? Instead of the square root, how about we write y squared plus 2y, the whole thing to the 1/2 power. All right? Instead of the radical, because that power, guess what? That 1/2 power, for that one we can use the smackdown rule to turn it into a coefficient, okay? Which is what I'm going to do in this case. So we will do a bunch of distributions, but notice this nested expression. When we work on nested expressions, preferably we work inside out. All right. So let's simplify the insides of the parentheses, get all the terms without parentheses, and then in the end we will distribute these 3 in the very front of this expression. All right. So smackdown rule. And well, everything else remains the same. So that's 3 log base 7 y minus 3 plus log base 7 y minus 3. Okay, keep this minus for a second. I know this minus will eventually change the sign of everything. We can do it in our heads, of course, but I'd rather spend one step. So minus log base, what's log base 7 of 7? Cancels, and the result will be 1. Perfect. Okay, plus log 7 base 7 of y plus 1/2 log base 7 of y squared plus 2y Or you know what? I'm gonna change my mind here because I know. Uh-huh. It's part of it. Well, check this expression y squared plus y plus 2y. It seems like that expression inside of the parentheses can be simplified, can be factored because we have a greatest common factor, isn't it? We have we can write it as y times y plus 2. All right? And well, what's going to happen here essentially, well, you know what, let me get rid of some of the parentheses. We may not need too many. All right? Okay. So we will further break up this product into a sum. However, do I want to do it now or until? Let's do it now. So this will be 3 log base 7 of y minus 3 plus log base 7 of y. Oh, that's supposed to be a plus and a plus, right? Plus 3. And then, well, that's minus 1 plus log base 7 of y plus 1/2. Okay, here is where we're going to write this as a product rule. Here, this product will become an addition. So that's 1/2 log base 7 of y plus 1/2 log base 7 of y plus 2. All right? And that's going to be, okay, first of all, overall parentheses and then brackets. Okay, change this to brackets at the same time. No need for curly braces anymore. Oh my God, I'm going to run out of space on this one. Well, at this point, we may distribute the negative over all these terms, but we can notice what's going to happen. We have log base 7 of y, 1/2 log base 7 of y. Those two look like terms, all right? And it's essentially, we're adding 1 plus 1/2. What is that going to be? 3/2. So I'm going to distribute -1 minus 3/2 log base 7 of y and minus 1/2 log base 7 of y plus 2. Everything else just remains the same. Log base 7 of y minus 3 plus log base 7 of y minus 3, and don't forget that this is still being multiplied by 3. And at this point, we may distribute that 3 from that we smacked down from the very beginning, because if we look at everything inside of the bracket, we will no longer have any like terms, right? They are all unlike terms. Check the arguments. I mean, the bases are the same to begin with, but what do we have? Y minus 3, y, come on. That was supposed to be a plus, right? Y and then y plus 2, they are all unlike arguments, so no like terms. So let's distribute the 3 over all these terms right here. All right? So let me do some magic here. And I'll make it fit. So 3 log base 7 of y minus 3 plus 3 log base 7 of y plus 3. 3 times -1, careful, that's minus 3, that's a -3. And well, 3 times -3/2, that's -9/2 log base 7 of y. And last but not least, we distribute the 3 times -1/2. That's simply -3/2 log base 7 of y plus 2. All right? And that's final answer, actually. That's final answer. I know this one was a huge one, but trust me, guys. This is how homework exercises may look like. Something you may see something like this in a future exam. And when we get to calculus, actually, hey, what's up? Yeah.
Where did you get the 3 halves from? Or negative 3 halves log 7 of log?
This one. So 3 times the negative 1/2, the coefficient.
Step before that one.
This one. Oh, this the 3/2. Oh, okay. Good question. That's because, let me highlight. This guy right here is like term with that guy over there. So the coefficient, that's an invisible one. So 1 plus 1/2, that's 3/2. All right? Okay? So this is how a lot of the, again, some of the homework exercises look like. You will have to deal with madnesses like this in calc. Yes?
So like, is a problem like this going to be on like the test, like multiple ones, or just like?
Maybe, hopefully not that ugly, but I mean, let's prepare for the worst, right? In the worst case scenario, well, you know how it looks like. I know it's a lot of writing, yes, but in the end, it's properties. Properties, combining like terms, this and that, you know. Okay, guys, so how about we stop here and we'll look at the next topic in the next lecture. I know. Yes.
Test.
I just got the information is no, it's actually I got the email before starting the class. Wait, where did I get this from? SHW. Storm Hall West. Yes, all exams. Exam 1, 2, and 3. Storm Hall. What I don't know about the final. And the makeup will be on Wednesday from 7 to 9 DMCS 333. I'm going to send an email.
What room is Storm Hall West?
Storm Hall West. Good question.
You don't know, you just know it's in Storm Hall?
Yes, yes, Storm Hall. Yeah, it's SHW. Storm Hall West. There's no map here, right?
Storm Hall's that way, but what room? Because there's...
Oh, 10. Huh. Yeah, good question. Good question. You mean the room, right?
Yeah.
012. 012.
So, okay, Storm Hall West.
Storm Hall West 012. I'm gonna send an email with the information later today.
Okay, cool.
As soon as I get home.
Thank you.
All right, my pleasure. Any other questions, guys?
It'll be on Tuesday, right?
Huh?
On Tuesday.
Tuesday, yes, and the makeup is on Wednesday. In case you have a conflict, say you have a lab or computer science, a physics class or another class, or yeah, that's pretty much the conflicts. There's a makeup the following day on Wednesday in GMCS 333, but I will also email that information as well, and I put it as an assignment. Yes? Storm Hall West 012.
Can we use a calculator?
I don't think so, but since you wouldn't be allowed to use a calculator, most likely you will be given exercises for which you don't need to compute like weird numbers, something like pretty basic, you know. My pleasure. What's
I have a
up?
question about one of the questions on the study guide.
Uh-huh.
It was about,
Yeah, let's have a look.